Okay, so today's lesson, we're going to talk about simple versus compound interest. Just before we get started, let's review some of these words that you will be seeing when you're talking about simple and compound interest, and in general with financial math. The word principal means the original amount, so the amount that you started out with. The opposite of principal would be amount, and this is the final amount. We also have interest with a capital I, or it's represented by the capital I, and this is the interest as a money amount. On the other hand, when we talk about interest rate, we're talking about the percentage of money that you're getting as a result of the loan or the investment. Okay, the other words that are important, we have balance. This is what is currently in your account. The word maturity just means when a financial agreement ends. So let's say you were borrowing money. You borrow money for 2 years. So at 2 years, your loan matures, meaning you have to pay all of your money back plus the interest that is owed. When we talk about maturity, we often talk about term. So sometimes it might be a 90-day term. And this is just the time period of the loan or investment. On the other hand, we have the word period, and that often refers to the number of times that you're getting interest. So these might not be super clear right now, but that's okay because once we start doing some examples, it will become more clear to you, all of these words. Okay, on slide 3, we have the situation where you're given $500 to invest for 10 years. You have the option of investing it at either 12% simple interest or 12% compound interest. Use the two options are modeled by the equations given. So I wrote the equations here. I'm going to let you type it in here so that we can look at the two models and see how they change. You're starting at exactly the same amount, but based on the agreement that you have, your interest is being paid out to you differently. So the first equation we're going to do is we're doing simple interest. We have 500 times 0.12 times 10 plus 500. Okay, so this is the amount that you're going to have at the end of 10 years. On the other hand, if you're doing compound interest, you're going to have 500 times 1 plus 0.12 to the power of 10. 1,552.92. Now, if I want to create an equation for this, I know that compound interest, I recognize that this is an exponential relation. I know that it's exponential because the 10 is representing the years, and I could replace it with an X so that it just shows the number of years. Simple interest, I can replace the 10 and put an X there as well to have the number of years change. Now, my X and Y axes, this field of view is way too small. So let me change it so that I can see my graph. Now we know that X axis is time and we're talking about years. Yes, we could do 0 to positive 10 years. And our y-axis, we're referring to the amount. And the amount is in dollars. Now, when we typed in the equation itself to find out what the amount is in 10 years, we know that it went up to 1,500. So let me just, maybe I'll go up to 2,000 so that I can see my graph. Okay, now when I zoom out, we see that there are two differences. The first one, simple interest, is represented by the green line. This is a straight line, and based on the equation and based on the way the graph looks, I can say for sure this is a linear relation. So that means every month or every year, I'm getting the same amount of interest. So it's a very constant rate of change. On the other hand, compound interest is represented by my purple line. Purple line, it's increasing, and then all of a sudden, it gets steep very quickly. Based on the shape of the graph and based on the equation, I can conclude that this is an exponential relation. Okay, so that answers our two questions here. So we know that simple interest is linear, and we know that it is because the variable has an exponent 1, and the graph is a straight line. On the other hand, compound interest, we know that this is exponential. The variable is the exponent, and the graph is L-shaped. Okay, so let's take a look at the two types of interest. I'm going to first talk about simple interest, and then we'll compare it to compound interest. So simple interest are two equations. We have I for interest is equal to the principal times the interest rate times the time. And then to get the final amount, we take the principal and we add the interest. Okay, so let's write this all down. I is our interest in dollars. P is the principal. R is our interest rate. And that has to be expressed as a decimal. And T is time in years. So when I say it's time in years, if I ever have something that is not in a full year, we can make it as a fraction of a year. So what I mean is, let's say we're talking about half a year. I need to write 1/2 to represent the half. Or if I want 90 days, I need to write 90 out of 365 days, and that's the fraction that represents the time in years. Okay, and then the final one, we have A here, the amount is principal plus interest. Let's go on to do a couple of examples based on what we know. Mary invested $3,500 in a term deposit that paid 7.5% for 5 years. How much money did she earn in interest, and how much money did she receive upon maturity? So at maturity, she's going to take back her original investment plus the interest. So let's organize our information here. We don't know. P, the principal, 3,500. The rate is 7.5%. So we're going to take 7.5 divided by 100 to make it a decimal, 0.075. And T is for 5 years. Let's take this information and we're going to insert it into our equation now. How much money did she earn in interest? Interest is equal to 3,500 times 0.075 times 5. Okay, we pull out the calculator. 3,500 times 0.75 times 5. Okay, so we know that she earned $1,312. Right? So that's part A. Part B, we need to find out what was the total amount she got at the end. So amount is equal to our principal plus interest. $3,500 plus $1,312.50. So at the end, she received $4,812.50. Let's do another question. This time, instead of an investment, we're going to be doing a question where you're owing money. So a credit card company charges 24% interest per year. Jimmy has an outstanding balance of $868.75 on his credit card for 35 days. How much money did he owe in interest? Sorry, there's a typo there. It's owe. And how much money did he need to pay altogether? Now let's sort out the information. So interest is what we're looking for. Principal is $868.75. Interest rate, 0.24. Now, time is going to be a fraction of a year. He only took this out for 35 days. But 35 days expressed as a fraction, we need to take 35 and divide it by 365. Right, so let's enter that into our equation. So 868.75 times 0.24 times 35 divided by 365. So let's throw that all into the calculator. So interest is $19.99. Okay, so in addition to what he owes the credit card company, he has to pay an additional $19.99. So our final amount, 868.75 plus 19.99. Okay, so Jimmy has to pay back $888.74 in total. Now, sometimes we're not only asked to find the interest, so we might have to rearrange the equation to solve for the variable. I know that you can do algebra, but I found that this was kind of an easy way to remember our equation because depending on what variable you're looking for, you can insert it into this chart to get your equation. So for example, if you're looking for the rate, just cover the letter R, and what you have left is your equation. So rate is equal to interest divided by principal times time. Let's do an example based on that. So upon maturity, Mushfig collected $1,000 saving bonds that earned 5.8% per year. He received $348 in interest. How long did he hold the bond? So we're looking for T in this case. I'm going to cross out the T, and I use the equation I is over P times R. Now, first of all, I'm going to sort out the information that I have. So I is equal to 348. P is 1,000. R is equal to 0.058. And we are looking for T. So we're going to take our T. T is equal to I divided by P times R. Right, let's insert the information that we have, 348 divided by 1,000 times 0.058. Right, so we get T is equal to 6. So we can conclude that Mushfig held the savings bond for 6 years. Let's do another question. A savings account initially had $17.80. At the end of 3 years, it received $170.25 in interest. What's the interest rate? Now remember, our interest rate is going to be given as a decimal when we calculate it. We need to make it into a percent afterwards. So interest, 170.25. Principal, 1780. Rate is unknown. and the time is 3 years. Okay, our equation is going to be I over P times T. So 1725 divided by 1780 times 3. So our rate, 0.03188. Okay, this is the decimal version of the percent. So my final answer, I need to find the interest rate as a percent. So I'm going to multiply this by 100, and I get the interest rate is 3.12, sorry, 3.19%. Okay, this question. Marlou earned $230 in interest from an investment that earned 5% over 7.5 years. What is the principal? Let's sort out the information. So interest, 230. Principal, we don't know. R, 0.05. And time, 7.5. So the equation that we're working with, P is equal to I over RT. So let's substitute our numbers in. P is equal to 230 divided by 0.05 times 7.5. Okay, let's go to the calculator. 230 divided by 0.05 times 7.5. And the principal, 613 and 33 cents. So Marlou's principal, 613.33. Okay, so slide number 8, I'm going to give you a couple of minutes to make sure you understand how to solve questions related to simple interest. I'll pause here for 5 minutes and then we'll take this up. Okay, class, let's take up the try this question on simple interest. If you had trouble, please follow along in this slide and take down the notes. I have put comments down on people's work who I did see, so hopefully that was clear. Okay, so Nurlan borrowed $7,000 for 181 days and had to pay $7,736 back when he returned it. What was the interest rate? So first of all, we need to find the amount of interest because what we have here is the final amount. So I know that A is equal to 7736. I is equal to, we don't know what I is equal to, but we know P is equal to 7,000. So that means our interest in dollars, $736. So for us to find the rate, we now have our interest, P is 7,000, R is unknown, and time is 181 over 365. We're expressing it as a fraction out of the total number of days. So our equation, we have R is equal to I over P times T. So 736 divided by 7,000 times 131 over 365. So throw that into your calculator and let the calculator do the work for you. Okay, so R is equal to 0.2120. Let's round it to 212. And as a percent, I need to multiply it by 100. So we're taking our decimal spot and we're moving it 2 spots to the right. So the interest rate is 21.2%. Okay, the next one. Eva borrowed $5,000 at 7% simple interest for 3 years. How much did she have to pay back in total? So we know that interest is what we're looking for. Principal is 5,000, interest 0.07, and time is equal to 3. So let's substitute our values in. Interest is equal to 5,000 times 0.07 times 3. So interest $1,050. She still has to pay back the $5,000. So now we're looking for the amount. Amount $5,000 plus 1,050. And the amount 6,050. Eva has to pay back $6,050 in total. Right, our next one, Caitlin invested $12,500, earning 5.5% in simple interest, and received $12,671.88 upon maturity. How many years did she invest the money? Okay, so we know this number is our amount. So because we know that amount is equal to P plus I, we can subtract the two to get our interest. So that means interest is equal to 1261.88 minus 12,500. So 171.88. Okay, so let's substitute it in our equation. T is equal to I over P times R. Okay, so T is equal to 171.88 divided by 12,500 times 0.055. Okay, so time is equal to 0.25. Now 0.25 is a quarter of a year. Now we know that a year is equal to 12 months. So if we took a quarter of 12 months, that would be equal to 3 months. So how many years did she invest the money? She invested it for a quarter of a year, or we could say she invested it for 3 months. Okay, the last question we have. Ali has $230, a $230 overdue credit card bill. His credit card company charges 23% interest, and he had to pay $20 of interest for being late. How many days late did he pay his credit card? Now, remember, it's 365 days in a year. Okay, let's sort out the information. So we know that the interest is $20, principal 230, rate is 0.23, and time, we're not sure, but we do know that it is in days. So I'm going to put D for days, 365. So let's continue on to do our equation. 20 is equal to 230 times 0.23, or sorry, I'm sorry, we could do T is equal to I over PR. Okay, so we have D is over 365 equals 20 divided by 230 times 0.23. Okay, we're going to simplify it more. I'm going to multiply the 365 to this side. So I have D is equal to 20 times 365 divided by 230 times 0.23. So days, 138 days. Right, so some of these were straightforward. Some of them were a little more challenging, especially if the time is not represented in years. So that's something that you need to be mindful of when you're doing simple interest. Now, the nice thing about simple interest is that this is a linear relation, and so it's fairly easy to do the algebra for it. That being said, whenever you see them referring to interest without the word compounding, then it's implied that this is a simple interest question. Now, let's take a look at compound interest. Compound interest is slightly different because we know that this is an exponential relation. Now, what makes it special is that the interest that you've earned, the next year, interest is going to be earned on the interest as well. And on the following year, all the interest plus the principal will all get additional interest. So your interest rate is growing. Whereas in simple interest, your interest rate was the same amount every single year. So in compound interest, you are getting, or interest is applied to both the principal and the already okay, so here's our fancy definition. Interest is applied to both principal and already accrued interest. So meaning the interest that you've earned, it's going to get interest as well. Okay, So compound interest, because we said that this is an exponential relation, it's going to be in the form of an exponential equation. So recall our exponential equation, y is equal to ab to the power x. Now, our compound interest equation is very similar to that. We have a is equal to p times 1 plus I to the power n. Now you'll see the similarities. A is the same as y, where we're talking about the amount. Principal is the original amount. And before we used the letter A to represent the original amount. B was our growth and decay rate, and we always took 1 and we added the percentage of growth. So we're doing the same thing. This is our growth rate. So we're taking 1 because interest is always growing. It's never a decay. So because it's growing, we're going to do the 1 plus I. And our x is the same as our n here. Okay, so for each of these, let's define what our value is. We have A represents our final amount. P is our principal, and sometimes it's P for present value, so the amount that you have now. I is the interest per compounding period, and N is our total number of compounding periods. So this is now slightly different. We said that in X, this is the total number of cycles. But here, our cycles mean the number of compounding periods. I was our growth percent. In this one, it's the interest per compounding period. So I'll give you an example. When we have something like this, an amount has 8% interest compounded quarterly. When I say that, it means that for the entire year, your interest will add up to 8%. But you're not getting 8% every quarter. It's just that you're going to get 2% each quarter, and that adds up to 8%. So when we do that, we need to take our 0.08 and we're dividing it by the number of compounding periods per year. Okay, so interest, this is our interest rate divided by number of compounding periods per year. So let's just review what it means when they're talking about compounding periods. So let's say we had compounding yearly or annually. We're talking about getting interest once a year. If it's semi-annually, we're talking about 2. Quarterly means 4 times. Monthly, we have 12. Weekly, 52. Bi-weekly means every other week. So there's 26 2-week periods in a year. And daily would be 365. So with the N, we have to be very careful that we take the rate and we have to see what kind of compounding it is. If it's compounded quarterly, we're dividing our interest rate by 4 so that each time we're getting 2%. the 2 plus 2 plus 2 plus 2 will eventually equal 8% in the whole year. Now, when we say n, we're talking about the total number of compounding periods. So if an amount is compounded semi-annually for 5 years, what's the total number of compounding periods? So we have n is equal to 5 times 2, because there's 2 compounding periods when we're talking about semi-annual. So n is equal to 10. Now, this is important because when we're using our calculations, we need to express our I and the n using this. Now, let's do a couple of examples. On slide 12, we have Sam is investing $3,200 for tuition when he goes to college in 2 years. If he invests his money at 6% per year compounded monthly, how much money will he have when he goes to college? So first, let's organize the information. We know that the information that we have A, P, I, and N. So when we first talk about investing, this is the original amount that he has, $3,200. Sam's going to go to college in 2 years. So we know 2 years is a part of the compounding period. But the money is going to be compounded monthly. So that means every single month he's going to be getting interest. So now we have to take 2 times 12 to get 24. So interest is applied to this money 24 times because it's happening every single month for the next 2 years. Now our interest rate, 6% per year compounded monthly. So 6% is the total we're getting for the year, but we have to divide that so that we get that by months. Okay, 0.06 divided by 12. The question is asking, how much money will he have when he goes to college? We're looking for our A. Okay, so let's type into our equation the information that we have, and then we'll solve it. So A is equal to 3,000 P. Okay, A is equal to 3,200 plus 1 plus 0.06 over 12, all to the power of 24. So let's throw in our values. I'm going to say with your I, keep it like that. This one works out nicely, but some of them will give you a repeating decimal. And when you have a repeating decimal, it's not super accurate if you were to round it. So keep it as a fraction and then only round it at the very end. So 3,200 times 1 plus 0.06 over 12 to the power of 24. So the final amount, $3,606.91. So Sam will have $3,606.96 when he goes to college. Okay, the next question, we have City Council voted to build a swimming pool in 3 years. They need to have $10 million to build it, and they have the opportunity to invest in some money. in a bond that pays 8.8% per annum, compounded quarterly. How much money should be invested now? So what are we looking for? Are we looking for the final amount or are we looking for the original amount? So people who are on this page, I'm going to give you an opportunity to click on the button where you feel is correct. Is it the original or the final amount? Very good, Mariam. Sadhana, what do you think? Okay, I'm going to give you a clue for those of you who aren't sure. How much money should be invested now? That's the question. Okay, so because we're looking for the amount now, we're looking for the principal. In the end, so 3 years later, they need to be able to fork out $10 million. Okay, so let's organize the information. We know that the amount is 10 million. The principal is currently unknown. Interest rate is 0.088 divided by 4 because we have our percent first expressed as a decimal and then divided by 4 so that this is done quarterly. And n is equal to 3 times 4 because we have 3 years and each year we're getting 4 times interest. Right, so now substitute this into the equation and we're going to use algebra to solve. So 10 is equal to P times 1 plus 0.088 divided by 4, all to the power of 12. Now we know that this part here, the bracket and the exponent, this is a power. And eventually, when I throw it into a calculator, this is going to be some solid number. I'm going to take this whole thing as a chunk and divide it because I know that the opposite of P times this would be dividing by this. So we have 10 divided by 1 plus 0.88, or sorry, 1.088 divided by 4, all to the power of 12, and this is equal to P. So let's put this into our calculator to solve for the principal. 10 divided by 1 plus 0.088 divided by 4 times 12. So P is equal to 7.70. Now remember, we're expressing our amount by millions. So since that was 10 million, we're looking at a principal of 7.7 million. So City Council should invest 7.7 million now. All right, let's do another 2 examples before I let you try some questions on your own. Okay, so a debt of $6,000 grew to be $8,940 when you paid it off 5 years later. The debt was compounded monthly. What's the interest rate? Okay, let's sort out the information that we have. We know that the final amount, 8,940, principal, which is the original amount, $6,000. Interest is what we don't know. But because the interest is compounded monthly, I know that I'm going to have my rate divided by 12, where R is the annual interest rate. And then we have N, 5 years, but every year we're getting interest 12 times. So I have 5 times 12, and that gives us 60 compounding periods. Great. Let's take this now, and we're going to put it into our equation and then use algebra to solve. So 8,940 is equal to 6,000 times 1 plus R divided by 12 to the power of 60. We're going to start peeling things away one thing at a time until we are just left with R. Now, 6,000 is being multiplied with this power. So let's divide both sides by 6,000. Okay, so we have this. Next, we need to undo this exponent in order for us to get rid of the bracket. Now we remember the opposite of the exponent would be the root of it. So since the exponent is 60, I'm going to take the 60th root of this monstrosity here. So 60th root of 8,940 divided by 6,000 is equal to 1 plus R over 12. Hey, let's put this into our calculator. Nth root 60 divided by 8,940 divided by 6,000. 1.006668. Okay, so 1.006668 is equal to 1 plus R divided by 12. Okay, let's continue on with algebra. I'm going to subtract 1 from both sides. So 0.006668 equals R divided by 12. So let's multiply 12 to both sides. And our rate 0.080016, let's leave it at that. So the rate was 8% per year, compounded monthly. Now this question, you know how to solve something like this using technology. Remember we said that we were able to write the two equations, one on each side, and find where the lines intersected. You have your curve on this side, and the left side is a straight line. Find the point of intersection and you've got your rate. So that's another way you can do it. You do have the algebra skills to solve it as well, so that's another tool. Now, for this question, this one is just solving using technology. You've invested $1,500 at 5% compounded semi-annually. How long will it take to grow to 2,000? Use technology to help you solve. Now, even though we're using technology, we still have to sort out our information so we know what equations we're entering into our graphing calculator. Right, first, we want to know when it's going to grow to $2,000. So that's the final amount that we want. The original investment, $15,000. The rate is 5% compounded semi-annually. So 0.05 divided by 2, because semi-annual means twice a year. And n is equal to an unknown number of years. That being said, it is semi-annual. So we have unknown years times, so I'll have years times 2, because there are 2 compounding periods in a semi-annual agreement. Okay, so our equation is now 2,000 equals 1,500 times 1 plus 0.05 divided by 2 to the power of 2y, where y is years. Okay, when we get here, we now need to go to our graphing calculator to type this into both sides. I didn't give you a slide with this, but you can go straight into Desmos to use it. Okay, so our left side is 2,000. Right side, 1,500. Sorry, I'm going to put X instead of Y. So where X is years, 1,500 times 1 plus 0.05 divided by 2, all to the power of 2x. .05. Okay. I did copy it properly. Okay, now we have to change our field of view to make sense of this graph. Now, once again, X is our years and Y is the amount in dollars. So we're looking for it as 2,000. I'll make it slightly over 2,000 so that I can see it. Okay, our point of intersection, 5.825 and 2,000. Okay, so our conclusion is after 6 years, we'll round it to 6 because they won't give you interest halfway through. It's either it has to be in the middle of the year or at the end of the year. So it's when you're getting your compound interest that you'll get all of it. It's not a continuous thing. So it's not like halfway through the year, you're at 2,000. You're going to have to wait till the end of the year before they actually credit you with all that interest. So after 6 years, the investment has grown to $2,000. Okay, so that's how we solved this question. Now, for the next slide, I've given you 2 questions for you to try on your own. You need to decide if it is present value or your final amount, and then decide how you're going to solve it. Most of the questions will be just using the equation in a straightforward manner. I think at the end, there might be 1 or 2 that you have to use a graph for. Okay, so please start working on slide number 14. I will take this up in about 10 minutes. Hi, class. Thank you to all those who are still here. Let's take up these questions and then we'll call it a day. So we have $1,225 invested for 14 years at 16% per year, compounded monthly. What are you going to have at maturity? Well, we're looking for the final amount because we know that this is the original investment. So let's sort out our information. A is unknown. P, 1,225. Interest is 0.06 divided by 12, and N is 14 years times 12. Now, one thing to note is, logically speaking, you know that your final amount has to be bigger than your principal because the final amount is going to be your principal plus the interest. So if you ever see an answer where you have something lower than your principal, then it should send a red flag to say this isn't really working out. All right, so let's substitute this in. A is equal to 1,225 times 1 plus 0.06 divided by 12, all to the power of 14 times 12. Okay, let's put this into the calculator. And amount $2,831.62. Okay, second question. John has a loan for $5,000 that's due in 4 years. He wants to pay off his debt early. The creditor is willing to discount the loan at an interest rate of 8% per year compounded monthly. How much would the creditor be willing to accept today? So this is definitely a present value question because this is what he has to pay in 4 years. But they said if you pay it early, you don't have to pay so much because you have interest that would be less than that you wouldn't have to pay as much interest. So let's go backwards. We know that A is 5,000, P is unknown, interest 0.08 divided by 12, and N is equal to 4 times 12. Right, so our equation, 5,000 is equal to P times 1 plus 0.08 divided by 12, all to the power of 48. So let's rearrange our equation and isolate for P. So 5,000 divided by 1 plus 0.08 divided by 12 to the power of 48. And now the calculator is going to do all the work for us. 5,000 divided by 1 plus 0.08 divided by 12 to 48. So principal now, 3,634 and 60 cents. So if John pays his debt today, he can pay 3,634 instead. Okay, so slides number 15 to 19 are practice questions, and slide number 20 has the answer key. Just a reminder that quiz number 4 has been assigned, and you have 1 week, or sorry, quiz 5 was assigned today. Quiz 4 was assigned Tuesday. Both of them you have a week. So quiz 4 you have until Tuesday, and quiz 5 you have until next Thursday. Okay, so that is it. Have yourself a good long weekend. And I will see you on Tuesday. Take care.